Today we'll be looking at the triangle inequality theorem. Now, the other day you did an exploration, or maybe it was today, and you figured out that some side lengths could form a triangle and other times you could not form a triangle with these side lengths. So if you noticed, like 4, 5, and 7, those lengths could make a triangle, but 4, 7, and 2 could not. Hopefully you got that idea, like if the two short sides were too short, no matter how you pulled them, you're trying, but they're too short, they won't meet up. So sometimes lengths are too short and they'll never meet. So they won't be able to form a triangle. Or sometimes even they will exactly meet, but they'll lie as like one line on top of another and you won't make a triangle. So basically what I want to do is take all of this and break it down into a few simple rules. So here's what the triangle inequality theorem states. It says if you have any three sides of a triangle, no matter what they are, call them A, B, and C, A and B, they have to add up, their lengths have to add up to be greater than C. Same, B and C must add up to be greater than A. And then A and C must add up to be greater than B. So basically, in short, it says the sum of any two sides of a triangle must be greater than the third side. And as you were working through the exploration, I think you had an opportunity to guess, well, why can you just check the short two sides? Well, yeah, if the short two sides add up to be greater than the longer side, then this is obviously going to work. So typically when I check it, I only check the short two sides. So let's do some problems with this. The first one is this. Will the following three side lengths form a triangle? So what needs to happen so that this triangle isn't like left in limbo, not closing up? The shortest two sides have to be greater. Their sum needs to be greater than the longest. So you look at the short two sides, in this case 5, 7, and you want to make sure they add up to be greater than 8. And 5 plus 7 is 15, is not 15. 5 plus 7 is 12, which is greater than 8. So yes, these side lengths could form a triangle. And if you want to be really detailed, you could just also show that 5 plus 8 is greater than 7, and 7 plus 8 is greater than 5. But I think that's kind of obviously true, so I don't usually require that you show all of that. Okay, let's check the next one. 3, 3, and 6. Will those form a triangle? Okay, you might want to pause the video and try this one on your own. Okay, if I check here, again, I'm going to look at the short two sides. 3 plus 3, I want to know if that's greater than 6. Well, 6 is not greater than 6. 6 is equal to 6. And this is going to be one of those triangles where you have 6, and then you have 3, and then you have 3, and it's making a straight line and not actually a triangle. So this, no, this does not work. It doesn't form a triangle. Okay, the last one, try this one on your own and see what happens. 10, 2, and 5. Okay, I hope you noticed that I tried to trick you here. I hope you picked up on it by throwing it so it wasn't in order least to greatest. So again, I'm going to check the short two sides. 2 plus 5, is that greater than 10? 2 plus 5 is only 7. It's not greater than 10. So no, this does not make a triangle. All right, we're going to dig a little bit deeper, and this time I'm going to give you two side lengths of a triangle, and your job is to figure out at least 3 other lengths that are possibilities for the third side. And then I want you to write an inequality to describe the range of possibilities. So we've got some options here if we think about this as a triangle. 3 is a side, 4 is a side length, and the other one, it might be the longest side, or maybe possibly 3 and 4 are squished together like this, and maybe I'm missing the shortest side. So we've kind of got to consider 2 scenarios here. So if 3 and 4 are the short two sides, then that means that this length, the long side, well, I know that 3 plus 4 has to be greater than, I'll call it x, because otherwise it's not going to meet. So this helps me to know that x has to be less than 7. Now in the second scenario, if x was the short side, then kind of notice that 4 is the long side. So in this case, x plus 3, those would be the two small sides. That has to be greater than 4. So I don't know if you can notice this, but x has to be greater than 1. In this case, my x values, it has to be less than 7, oops, but also greater than 1. So this is the inequality. I guess I did that one first. Second, you want to write 3 side lengths that it can be. So you just pick anything between 1 and 7. So maybe you're going to pick 2, 3, 5. Maybe you'll get creative. You might have put like 3 1/4, pi, ... Okay, so anything in between 1 and 7 that's not equal to 1 or not equal to 7 would work. All right, let's look at that last one. 1 and 1, they're my 2 side lengths. Okay. So again, if 1 and 1 are my short sides, then I'm trying to see what's going to be this long side. Call it x. Or I could also possibly have 1 and 1 be the long sides and have this x being the little guy here. So in the first case, I know that 1 plus 1 has to be greater than x. In the second case, I know that x plus 1 has to be greater than 1. So it's a little bit, this is a little trickier, I think, because it's a smaller range of numbers. So in this first case, 1 plus 1 is 2. So 2 is bigger than x, which means x has to be less than 2. You can't have a number bigger than 2, it's not going to make the triangle. In the third one, if x plus 1 is greater than 1, well, x just has to be greater than 0 in this case. So x has to be greater than 0. When we check this, we have to pick numbers that are bigger than 0 and less than 2. So it could be maybe 1, 0.5, 1 2/3, ... Make sure you got at least 3 number choices there. All right, thanks for learning about the triangle inequality theorem, and good luck moving on.